So here we go. For section 3, we're going to use logs now to solve. But the trick is, we're actually, do I have everybody's full attention? We're actually not going to use logs like we were learning them the last couple of days. It's mostly just practicing exponents, which will help us, go ahead and solve later on. Having a good understanding of how the exponents work, getting the practice here, will help us later on when we will use logs and the exponents to solve. Most of what we're doing today is just rewriting what we're given. Can we rewrite it in a way that we recognize and that we can solve easily? So for example here, is everybody good with the fact that if I have an equation where there's an exponent on both sides? So for example, make this nice and big here. If I have 3 to the x power equals 3 to the 5th power, does everybody understand that x has to be 5? That's the only way that this can work. The 3's are superfluous. They're extra for solving this because they already match. Does that make sense to everybody? If they already match, I don't have to do any work with them. So if I can write an equation where it's a base to a power equals the same base to a power, I can just take the exponents and make a new equation with them. I'm actually not canceling out the bases. I'm just rewriting a new equation with the exponents, the piece that needs to match. So often we'll call it dropping the bases, just getting rid of them because we don't need them, and taking the equation that's left over and solving for x. Now, it's not as simple oftentimes as just 3 to the x equals 3 to the 5th power. So everybody's full attention, because this is what everything we're doing today is built off of. Right here, I have an 8 and a 32. For everything we do today, both of those numbers will be able to be rewritten as one similar number to a power. So the 8 and the 32 are both powers of 2. I can rewrite the 8 as 2 to the 3rd power. Does that make sense to everybody? So this 8 is 2 to the 3rd power. The 32 is also 2 to a power. This 32, 2, 4, 8, 16, 32. It's 5 2s. And again, you can just use a calculator to check that. Now, this isn't quite right yet. 1 over 32 means I need a negative exponent. Does that make sense to everybody? That's going to get me the 1 over 32, would be that negative 5. And then over here, we already had an exponent. And so we need to think back to some of our rules of exponents. If I have x to the a power raised to the b power, I raise a power to another power, I multiply those. So this would be x to the a times b. So that's what I'm going to use right now. On this side, I had this x exponent. That is going to go right here. It's going to be multiplied by the new exponent that I found. So now I have an equation where there's a base on both sides that matches. They're both 2 to a power. Every single thing we're doing today requires us to be able to rewrite it like that. At the end of the unit, I will teach you how to solve these where the bases don't match, okay? If it's 2 to a power equals 3 to a power, I will show you how to do that. We're not doing that today. So here, 2 to the 3x equals 2 to the negative 5th. This would then be a new equation, 3 times x equals negative 5. And typically, you'll end up with an equation that you solved in Math 1, something that's super easy. Here, we're just going to divide both sides by 3. Divide by 3. Divide by 3. X is equal to negative 5/3. All right, there's lots of chatting. Do we have questions? Did that make sense? It'll take some practice to get used to this. But the idea here we could break this all the way down. I could work you through how this works. 8, the cube root of 8, right? The 3 on the bottom means the cube root. The cube root of 8 would be 2. 2 to the 5th power is 32. And the negative flips it upside down. Does that make sense? You don't have to be able to think through that, but that's how you could check your answer. Next one. Number 2. 9 to the 4 plus x equals 3. Okay. I can't do anything with that 3. Doesn't break apart. I can, though, explicitly say that it has an exponent of 1. Does that make sense to everybody? That 3 is 3 to the 1st power. So then I better hope that the other side can be 3 to a power, or I can't solve this right now. 9, can I write 9 as 3 to a power? Right? 3 to the 2nd power. So rewrite this. 3 squared times the exponent that was already there. 4 plus x. Now that the 3's match, take the exponents, make a new equation. 2 times 4 plus x equals 1. Do the distributive property, solve like normal. 2 times 4 is 8. 2 times x is 2x. Subtract that 8 from both sides. We get 2x equals -7. Divide both sides by 2. Final answer, x is -7 over 2. Does that make sense? Are we okay? Let's do a couple more and then you guys can try it. Number 3. Okay, again, you guys, phones away. Shouldn't need a phone for anything right now. We want to make sure that you've got this down because we're going to build on this. Number 3, 4 to the 2x minus 6. I have 2 options for this one. I can either write this as 2 to a power on both sides, or probably easier to go ahead and just write the 16 as 4 squared. As long as the bases match, I'm fine. So this one, 4 to the 2x minus 6 equals 4 squared. Set the exponents equal. 2x minus 6 equals 2. Add 6. 2x equals 8. Divide by 2. X is 4. Is everybody good with that? I didn't write down every single step, but is everybody good with how we work that one out? If you get an answer that is this simple, like a nice whole number answer, it's actually not hard to plug it back in and check. 2 times 4 would be 8. 8 minus 6 is 2. 4 squared is indeed 16. Does that make sense to everybody? Yes? No? Most of us are okay? All right, so then number 4. Let's do this one and then I'll have you guys try it. Number 4, 49 to the negative x plus 3 is equal to 7 to the 2x. I've got to be able to write this as 7 to a power. Luckily, 49 is 7 squared. So 7 squared times, now this is going to be a little interesting, right? That negative, I need to remember it's multiplied by negative x plus 3. Not subtracted, multiplied by that. Equals 7 to the 2x. So a cleaner way to write this is probably to multiply the 2 and the -1, make this -2 times x plus 3 equals 2x. Then I can do the distributive property. -2x minus 6 equals 2x. It's a 2-step equation. Add 2x to both sides. So if I add 2x to both sides plus 2x, I get -6 equals 4x. Can divide both sides by 4. Negative 6 over 4 is going to be negative 3 over 2. There's my answer. So the goal every time is to get the bases to match. They have to be something to a power, and that something has to be the same. Once you've got that, then set the exponents equal and solve that equation. The homework here is numbers 2 through 40 even. Right now, you're set to solve numbers 2 through 12, okay? You should be able to solve 2 through 12 right now. Go ahead and start off. Actually, I'm going to ask you guys to do numbers 1 and 2 first. Even though I didn't assign number 1, I want you to try it right now as practice. 1 and 2 right now. Go on from there if you are feeling good. So again, for some of these, we're not going to actually solve it. I'm going to assume you can do that on your own. If not, please let me know. So like number 5, this is 10 to the 3rd power times what was already there, x minus 5. This 100 would be 10 squared times 4 minus x. Okay, there's too much chatting and other stuff going on right now. I want to make sure you've got this down. Alejandro, put it away. So at this point, we've got 3 times x minus 5 on one side equals 2 times 4 minus x on the other side. And the hope is everybody could solve that, do the distributive property, work it out. Next one, take that 32, make it 2 to the 5th power times the x that was already there. This one's already 2 to the x plus 3. So you can write it x plus 3 equals 5x and solve that. Is everybody like, you see that equation, you think you can finish it? Again, if you have any hesitancies with those, let me know. Here's where we may have some issues. Square roots. Remember, square roots are just exponents, fraction exponents. So this guy right here, 2 to the x power. Is everybody good with 8 being 2 to the 3rd power? And the square root right here. The square root is a 1/2 exponent. Is that too bright? Can we read it? Everybody's good? The square root means 1 over 2 as an exponent. So that becomes 3 over 2. And this one is already solved then. X, yeah, we'll leave it as red then. Maybe that'll be easier to see. The square root is over 2, right? 8 is 2 to the 3 over 2 power, just like we did in unit 6. So my answer here, x is equal to 3 over 2. Number 8, this is where, right here, this is as hard as these are going to get. These are all 5 to a power. This is 5 to the x power. 25 is 5 squared. And the square root of 5 is 5 to the 1/2 power. In order to solve this, you need another exponent rule that we haven't used yet. You've used it before, but not today. Anybody remember if I have 2 bases, I multiply them, what do I do with the exponents? We add them. Does that make sense? So this is going to be 2 plus 1/2. 5 to the x equals 5 to the 2 plus 1/2. So really, my answer is just x equals 2 plus 1/2, or 2.5. That would be a fine answer. I would really prefer 5 over 2. That's going to be easier to use later on. But if you put 2 and 1/2, that's fine. Does that make sense to everybody? So that one, I had to take the 2 pieces and put them together. Now, for those of you that want to be able to work ahead, I'm going to give you one example of what's coming up. Oh, actually, no, these are just reviews. IOH logarithm. This is all just practice from what you've done before. So number 10, log base 5 of 5 root 5. Every single one of these down here, you guys, the goal is for you to write it so that it's log base b of b to a power, and your answer is the power. That's what we're going to try to do for everything 10 through, what is it, 18? So like this one, log base 5 of 5 root 5. I'm going to rewrite that. Log base 5 of 5 times 5 to the 1/2 power. I can combine those. This is 5 to the 1st power. This is 5 to the 1/2 power. 1 plus 1/2. You could say 1 1/2, or you could say 3 over 2. Either way, though, when I combine this, my answer is going to be 1 1/2. Let's go ahead and show the work, though. Log base 5 of 5 to the 1 1/2, or 1 plus 1 over 2, or 3 over 2, however you want to write that. As long as you can write it so these bases match, your answer is the exponent, 1 1/2. Now, there's many ways you could do this. As long as you follow the rules of exponents, you'll be okay. Number 11, log base 4 of 16 root 4. Log base 4 of 16 is 4 squared. Square root of 4 is 4 to the 1/2. Add those exponents. Log base 4 of 4 to the 2 plus 1/2. That exponent is my answer, 2 1/2. All right, and 12. This is where we get into some interesting gymnastics, some mental gymnastics. How do I make this even work? Well, remember that we talked about, if I know what log, let's start with this. What would log base 2 of 16 be? Let's try a simpler one. Before, right? 2 to the 4th power. So we'd said that if I swap those, I should get the reciprocal answer. So we're getting closer. If I just had log base 16 of 2, that would be 1 over 4. Oh, but I already have an exponent here. I already have a square root. So one way to do this is to say, well, normally I'd have a 1/2 answer for just the square root there, that exponent of 1 over 2. What if this was 1 over 8? Let's check. 16 to the 1 over 8. Let's rewrite that. 16 would be 2 to the 4th power to the 1 over 8. If I multiply those, 4 times 1 over 8, 4 over 8 would be 2, or 1 over 2. The square root of 2. That's what I'm looking for. So I have the right answer right now. The right answer is 1 over 8. But that was kind of a weird way to get there. Here's another way. I'm going to give you a little preview of what's coming up later. So if I'm not sure, I'm looking at this, I can't figure out how to make this work. Let's rewrite it in terms of an equation. 16 to some power equals 2 to the 1/2 power. Does everybody see what I just did there? I rewrote this. What power of 16 gives me the square root of 2? So 16 to some power gives me 2 to the 1 over 2 power. Doesn't this look like what you were just doing? So you're going to solve this the exact same way we did the other ones. Rewrite it. This one's 16 to the x power. This is 2 to the 4x equals 2 to the 1/2 power. 4x equals 1 over 2. Divide by 4. X is 1 over 8. That's a little bit more of a specific step-by-step way of solving that one. rather than just doing the mental gymnastics of, okay, what power of 16 gives me 2 to the 1/2 power? Does that make sense to everybody? At this point, for the homework, you should be able to get yourself all the way through, I don't know, you could get up through number 12, definitely. And you could probably do several of the ones after that. I wouldn't try going on to 24 or beyond, okay? Tomorrow, we'll pick up where we stopped. Eventually, you're going to be doing all these, 2 through 40 even. That's going to be the homework for tomorrow. So if you want to get a head start, get as much done as you can. You got about 5 minutes here. Knock out a couple problems. Ask myself or Emily if you have any questions. Let's see what we can get done in the next 5 minutes, though.